All right, in all three of the examples that you see on the screen right now, you are permitted to just cancel out the ln because of this rule here. If the logs match and their bases match, you can ignore the ln and set x squared minus 16 equal to 6x. Let's go right down to the next problem and do that step again. They're both base 5. There's nothing else around it, right? There's no number being added or multiplied. So it turns into that. X squared minus 45 equals 4x. The same down here in B, the ln's cancel, and you have negative 4x minus 1 equaling 4x squared. All right, so these log equations quickly turned into quadratic equations. We're no longer thinking of these in terms of solving a natural log, a log base 5, but we need to keep that in the back of our mind, that ultimately the solutions that we get don't need to just work in this quadratic or these quadratics that you see in red. They need to work back in the original equation. So that's why the top of the paper says, beware of extraneous solutions. Okay? In every case, in the green step, my goal is to get everybody on one side equal to 0. So in the first one, I'm going to subtract the 6x over to the left. In the second one, I'm going to subtract the 4x over to the left. And in the last one, I'm actually going to leave 4x squared over on the right because it's positive. I'm going to add the 4x over to the right and add the 1 over to the right. So here's what I did. Some of your middle school teachers might have written it out like that, where you go straight across and you add or subtract what you're doing in order to get the equation to the next step. All right, in all three cases, we need to factor. They're all factorable. So we're going to set up our two sets of parentheses. X times x makes x squared. Anytime the c is negative, put a plus and a minus down. So I need factors of 16 that are going to make a negative 6 in the middle. I think I'm going to give the plus sign a 2 and the minus sign an 8. That'll make a negative 16 and a negative 6x in the middle. Next one down. We're just knocking out every problem sort of at once here. I'm showing you every step 3 times. Next one down. We're going to do a plus minus again because of the negative 45. I think 9 and 5 are going to be good to go here. Let's give the 5 the plus sign and the negative 9. Give the 9 the minus sign. That'll give you the minus 4x in the middle. And then this one is actually the difference of two squares. 2x, 2x makes 4x squared. Positive 1 makes 1 when multiplied. And furthermore, the outside-inside combination is going to give you 2x plus 2x, which is 4x. So, quadratics have been factored. Time to do some solving. X equals negative 2, x equals 8, because we're looking for the opposites, so that when you do 8 minus 8, you get 0. When you do negative 2 plus 2, you get 0. X equals negative 5, x equals 9. Because you want to produce 0 there. In the last one, anytime there's a lead coefficient, sometimes people get a little confused. The answer is negative 0.5. Here's why. You can set it equal to 0, take away 1, divide by 2. Negative 1/2 is the other solution. So There are 5 solutions sitting on the screen right now. -2 and 8 for the first one, -5 and 9 for the second one, and -1/2 for the third one. Of these 5 solutions, only 3 of them work. 2 need to be thrown out. So we'll go over that now. And I'm going to show you a couple different ways of how I know we have extraneous solutions. First of all, I'm going to show you the first one on a graph. I already have this loaded in my calculator, so instead of you trying to keep up with punching all of it in, just watch, okay? So on my calculator, I have the original problem. The left side is my y1. The right side is my y2. We think that there are 2 solutions, 8 and -2. But when you look at the graph on the calculator, there are the equations. As you can see, it looks like they only cross 1 time, right? Over here at x equals 8. I think that is the only solution. I don't see them intersecting over at -2 at all, right? The red graph, by the way, the one with the ln of x squared minus 16, that's a little weird. It looks like a little antenna going in 2 directions or something. It has 2 sides to it. But the blue one, the other, I think it was log of 6x, right? ln of 6x. Well, that just lives over here, and there's an asymptote there. It's never going to come over here and get to -2. In fact, the function is undefined over there. If I take -2 and try to plug it in right here, I would say the ln of -12, and you can't do that. Negative numbers aren't in the domain of a log. So only 8 is a valid answer. Okay? In the next one, -5 is invalid because if you plug it in, it's not because it's -5, right? And all negative answers are bad. It's because when you plug it in, you do 4 times -5 on the right, and you can't take the log of -20. Even if you put it in on the left, -5 squared is 25. 25 minus 45 is -20. You can't take the log of -20. So we cross this out. 9 is good, because 9 squared minus 45 is 36. That's a positive. 9 times 4 is 36. So obviously, the log of 36 base 5 is equal to the log of 36 base 5. That's a good answer. And I like how they have this last problem here, because -1/2 might lead you to believe that, oh, it's got to be extraneous because it's negative. Well, it's actually not extraneous, because when you square a -1/2, you get positive 1/4. 1/4 times 4 is 1. So the right side says the ln of 1. That's okay. We can take the natural log of 1. The left side would have you take -1/2 times -4. Well, that's positive 2. And 2 minus 1 is 1. In either case, we have the ln of 1 equals the ln of 1. It checks out. That answer's good.